In this problem, we want to use implicit differentiation to find the derivative of 5x to the fourth plus e to the power of 3xy equals 406 at the point 30. Now y is not explicitly solved for here, it's up here in this exponent. So to differentiate this equation, we're going to actually take the derivative of both whole sides. So for the derivative of the left, I'll have the derivative of 5x to the fourth plus e to the 3xy, and that equals the derivative of 406. Now for the derivative of 5x to the fourth, we bring the 4 down, multiply it times the 5 to get 20x cubed. And for the derivative of e to the 3xy, we're going to use the derivative rule, which says that the derivative of e to the x is itself. Or if you have the derivative of e to a function, then by the chain rule, it is e to that inside function times the derivative of that function that's up there in the exponent. So for this, we're going to have to use the chain rule. So the derivative of e to the 3xy is itself, that's this part, e to the 3xy, times the derivative of 3xy. For the derivative of 3xy, we need to use the product rule. For product rule, I'm going to group the 3x together as my first factor and think of the y as my second factor. So my first factor is 3x times the derivative of y is dy dx, plus the second factor is y times the derivative of 3x is 3. So that's the derivative of the left, and on the right the derivative of a constant by itself equals 0. And now we want to find the derivative at the point 30, so we can go ahead and plug that in. We need to solve for dy dx, but it's easier to solve if we go ahead and plug in the point 3 for x and 0 for y before we do that solving. So plugging in 3 for x, we'll have 20 times 3 cubed plus e to the 3 times 0 times 3x is 3 times 3. dy dx is the derivative, that's what we're trying to solve for, plus y is 0. Okay, so 3 cubed is 27, so we have 27 times 20. Let's do that calculation real quick here. So 27 times 20 is 540, right there, plus e to the 0 is 1. This would be 9 dy dx, and that term is 0. So let's subtract 540 from both sides to get 9 times dy dx equals negative 540. So dy dx, this isn't really the derivative everywhere, this is actually only the derivative at the point 30. But anyways, it equals negative 540 divided by 9, so we get 60, negative 60.